Hello students. Now I am going to explain dielectric constant of a given material. Here the aim of the experiment is to determine the dielectric constant of a given dielectric material. Here the apparatus required are, here I will show you. Here this is the dielectric constant of a solid using frequency kit, and here we have dielectric materials we have inserted in this two. In this, here we kept glass material, here we kept here PZT material. For these two, now we are going to find out the dielectric material. Here you can see the formula used to find the dielectric material is here C into D, K is equal to C into D by epsilon naught into A. Here C means capacitance with dielectric, D is the distance between the parallel plates, here area of the metallic plate is A. So here to find this one, first we need to connect the apparatus. First take here, these are the connecting wires, take two connecting wires, connect like this. Here frequency to frequency terminals, here can connect, and then take two more cables and connect sample. First connect to the here sample is mentioned in the circuit. Here for glass we have to connect. First we need to find out the dielectric constant of a glass. For that we have to take the readings. So here connect, here mentioned sample to sample we need to connect, and then after so connect here two cables to the DPM, digital panel meter. From the resistor, across the resistor we need to take the voltage, so that we need to just connect here these connections. So once see the circuit diagram, here I connected according to the circuit diagram. All the connections I have given. First I have given this one VR, we need to find out VR. Find, then after first switch on the mains. So it is showing reading. So this actually gives VR value. That VR value I have noted as 1.47. Then after getting VR value, now we want VC value for the same glass material. So for that just switch off the power and then remove these two connections and connect across the capacitor. That means here red to red, this one red to red, and black to black. Then after switch on the mains, again it is showing some reading that you need to tabulate. Here 1.34, here it is showing some other value, but material to material it is different. I calculated these values previously, that's why I mentioned here. So like this you will get the values, that's it. So then after again change the sample. So first we have connected glass, right? Then after connect the same power, switch of the power, then again connect this one to the PZT, and then remove this one. Again switch on the power, again it is across the capacitor only we mentioned, that you have to note down here 0.33. okay, so that you will get some value. Then after again change the values, switch off the power, again connect this to the across the resistor, we have to take the reading VR value. So again switch on the power, it is showing some value that I already tabulated 1.68. so these are the readings we got. After getting these readings we have some calculations like this. So individually calculate separately, like for glass and for BJT. For glass I mentioned like this. Next we have I value, X value, capacitive reactance value, XC, and then capacitance value, and finally dielectric constant value. So one by one, step by step, you need to remember all the formulas. By using those formulas, here you need to calculate all the values. After getting these values, mention those values in the tabular form. It's easy for you in your exam. So I calculated for glass. Finally for glass I got dielectric constant value 13.4. Similarly for PJT also you need to calculate I value, capacitive reactance value, and also capacitance value, and finally dielectric constant value. So these calculations are little bit complex, not much, but you have to practice once, so that you will get a final value for the PJT lead zirconate titanate sample is 1090. So I mentioned those two values in the results. This is all about the experiment, dielectric constant experiment. Thank you.